questions do we have from any homework question? I got them all locked and loaded. Yeah, Ty. 9 on Y. So first of all, we do have pictures that we should have drawn. I know I didn't ask you to, but we should get in the habit of drawing them because it makes our life just a little bit easier. So I have D. Okay. 11Y. Okay, we'll go to 11. Same thing, just different letters. I'll have a triangle equals another triangle, or is congruent to. So I'll have BTS. I'll go B up, down. I'll go G, H, D. And then we have a BS equaling 25. Well, that must mean that GD is also 25 because those are the corresponding parts. Then it says TS is 14. Well, I'll put a double mark on there as 14, which would make our HD also 14. It gives us BT is 31. I'll put a triple. BT is 31, which would make HG 31. Then they must give us some other information. So they said GD equals 4x minus 11. GD equals 4x minus 11. So this one right here would be 4x minus 11. Well, this wasn't your question. I'm just going to go through it. So we should have a 4x minus 11 equals that 25 because they occupy the exact same space. Well, if I add 11 to both sides, we'll have 4x equals 36. And then we'll go ahead and we're going to have x equals 9. But your question wasn't x, it was y, right? Okay, so let's keep going. So our next one says measure of angle S is 56 degrees. It also tells us the measure of angle B equals 21 degrees. Says measure of angle H is 7y plus 5. Well, we don't have that labeled on either one of these, but notice how here it gives me 2 angles. How do I get from 2 angles to get to that third angle? Because I'm going to raise your hand and tell me how, if I have 2 angles, how do I get to that third missing angle? Yeah, Savar. Set it equal to 180. So we could go through the whole rigmarole. We could have, okay, all 3 of these angles, this angle, this angle, and this angle, must equal 180. So that means measure of angle S plus the measure of angle B plus the measure of angle T has to equal 180 degrees. Well, we know 2 of those values. We know the 25 for S. We have the 21 for B. So realistically, we just have to do 180 minus 25 minus that 21. Wait, it should have been 56, shouldn't it have been? One of those should be 56. Measure of angle S was 56. Let's erase that. That was 56. That doesn't seem right. There we go. So we have 56 and we have 21 degrees. We subtract that from 180. Well, what does the measure of angle T equal then? 93. Can someone second that?
97.
I heard a 97. I heard a 103. Can anyone second any of those guesses? 103? We're good with 103? Okay, then we have 103 for T, which is the same as H. So I could put a little mark right here and say that's 103. And we could solve for y by going, oh, that means that's 7y plus 5 equals 103. Is that far enough, Ty? Good? Other questions? Yeah. Number 8. Number 8 says, given triangle PRS is congruent to CFH, find the values of X, Y, and Z. Well, the big thing is make sure you're marking things correctly. P is congruent to C. So I should go, okay, P and C are congruent. We should say R is congruent to S. R is congruent to S. Oh, I'm sorry. R is congruent to F, I should say. And then S must be congruent to H. We can also notice that PS is labeled. Well, PS is first and last. That must be is congruent to CF, which is also first and last. CF is right here. Yeah. It should be CH. Yep, thank you. CH should have that tick mark on there. I said it first and last. I just didn't say the letters. Okay, so that means these are all our equations. One of our equations should be 2x minus 1 equals 39. Another equation should be, it looks like we have that 13y minus 1 is in the same place as this square right here, which means 90 degrees. So we should have 13y minus 1 equals 90. And then our final one is, oh boy, we don't have that missing angle. I don't have something for 6z minus 4. I'm going to go ahead and write that. And I have a triple mark. I don't have a triple mark right there. What do I do? Yeah.
Add them all up so you equal 180.
We can add them all up to equal 180. And one step further, we can go ahead and say this is 28 right here. So we know that this angle right here is going to be 180 minus the 28 minus the 90. Yes?
Why is it not 90 minus 28?
Why isn't it? Say it again?
Isn't that a right triangle?
That's why I put a 90 in there. I'm saying that this, if all of these added up equal 180, we have 180 equals 90 plus 28 plus this one, which means I would have 180 minus 90 minus 20. I'm just shortcutting it. Because this would actually be 180 equals angle H plus measure of angle C plus measure of angle F, which should be 180 equals H we don't know. C is going to be 28, and angle F is 90 degrees. That's why we can just go, 180 minus the two known angles will be our unknown angle. Is that clear where the 90 came from? So it'd be 180 minus 28 equals 90 would go right there. And the rest would be how you'd solve it. Okay? Are other questions? Okay, then today we're going to move on to triangle congruence statements. These are postulates. These are on that postulate sheet that I handed out to you. Like I said, it's probably a good idea to have that attached to the other postulate sheets, maybe staple it. I do have a stapler over there, just so we have everything together. The first part, we're only going to learn two things today. There's a whole bunch of them on that sheet, but we're just going to talk about two of them. The first one we're going to talk about is the side-side-side postulate. The side-side-side postulate says if three sides of one triangle are congruent to three sides of another triangle, then the triangles are in fact congruent. And remember, as soon as we say all the triangles are congruent, that means everything is congruent. The angles are all congruent and all the sides are congruent. So today we're talking about how do I prove that triangles are in fact congruent? And I want to be able to do it without using every single part. So to prove triangles are congruent, typically we need three elements. So the first thing we're going to talk about is side, side, side. If I can show that two triangles have three pairs of sides that are all congruent between them, that means the triangles themselves are congruent to each other. So to prove side, 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 you must be able to show that all the sides are congruent. So that means if I can say, AB is congruent to DE, and I can do that with two more sides, so let's do BC is congruent to EF, and we could do that to the bottom pair. Let's go ahead, AC is congruent to DF. Then we can say these triangles are in fact congruent. That's when we can do our congruency statement. So I could do something like triangle ABC is congruent to triangle DEF. So if I can show that three sides are congruent between triangles, I can now say they are in fact 100% congruent. That means I could say the angles are congruent. So now I can say A is congruent to D, B is congruent to E, C is congruent to F. Those triangles are in fact congruent, basically the same triangle. So if we could take three sides, prove that they're congruent, then we can say by side, those triangles are congruent as well. So that leads us into our first proof of these lessons. And that is, we are given a bunch of information, and we need to prove that these triangles are congruent. Do you notice how I didn't say what triangle it's congruent to? That's going to be you to decide. The first one is the easy one to list. The second one is the hard one to list. So when we get to step 4, we have to figure out what triangles are in fact congruent. But that's going to be based upon what marks we make and what order things are in fact congruent. So let's go through this. I think, I have enough room to do these first things. So we have PQ is congruent to ST. We should probably mark that. PQ is congruent to ST. And we have QR is congruent to TR. So I'll put a double tick mark, I'm going to go ahead and state those for my given. PQ is congruent to ST. And we also have QR is congruent to TR. I'm going to write my next given on the second line. I have R is the midpoint. That will also be given. I want you right now, talk to your partner or maybe the people in front of you. So Max and Joseph, you could turn around. I want you guys to say thank you, Joseph, if you want to help bring Xavier into the fold kind of thing. Daniel, you can just turn around since your partner's missing. Discuss why this is important to the problem. What would my next step probably be? Why is this R is the midpoint of PS important? So I should hear you guys talking about why that's important and what your next step might be. And once again, Max, if you could turn around and maybe turn back there. And come up with something to do. If you guys could turn around for this stuff. What would our next step be? What marks could we make? Why can we make them? All right, guys. What's step 3? Who thinks they know what I should write on step 3? Go. PR is congruent to, and you said RS?
Yes.
And what was your reasoning for that?
Definition of a midpoint.
Definition of a midpoint. Do we agree with that? Guys, you got to be aware of that. Midpoints show up a ton on this. It's just an easy way to come up with two sides that are in fact congruent. So if you see midpoint, you should go, oh, definition of midpoint says I have two congruent segments. Now, do I have three sides congruent to three sides of another triangle? Yes. So now we can say that the triangles are in fact congruent. So I have triangle PQR. Who wants to take a shot at the congruency statement? I wrote PQR. You have to write a statement that matches PQR, but with the other triangle. We cannot just guess. Ty? RST. Now, hang on. Let's check it. Here's an easy way to check these. So what I do when I'm doing PQR, follow along with me, especially if you're not sure what's going on. PQR, to get from P to Q, do you see how it goes across one tick mark? And then to get from R or Q to R, it goes across two tick marks. So it's one tick mark, then two tick marks. So if I did RST, guys, can you just stop for a second? RST would go across 3 tick marks and then 1 tick mark. Did that follow that 1 tick mark, 2 tick mark?
Yeah.
Hang on, I'll say that again. Maybe I'll write it up here. So PQR goes from P to Q to R. That goes 1 tick mark, then 2 tick marks. And then to go back, it'd be 3 tick marks. If I was using RST, that would be 3 tick marks, then 1 tick mark. Does that match exactly the same path? Ty, do you want to correct that one?
Yeah, it's STR.
It is STR would be correct. So we should change this to STR. Which would be correct. So triangle PQR is congruent to STR, and that would be by side, side, side. Our next one is a very big one that we have to pay attention to. We're going to add something that we haven't talked about much. So we have AC is congruent to AD. That's a given. Let's go ahead and write that. AC, AD. Then we also have that CB is congruent to DB. And that's all given. Well, we only know one. We only know side, side, side. We're going to learn other ones, but right now we know side, side, side. So that must mean my next step is showing that this line is equal to this. Does that at least make sense? I'll put the marks on there. Does it make sense that AB would have to be congruent to itself? Are you equal to yourself?
Yes.
If this was 6, wouldn't it be 6 on both triangles?
Yes.
Yes, you are equal to yourself. A segment's equal to itself. A length is equal to itself. Now, we have a rule in our packets that say you are, in fact, equal to yourself. That X is equal to X. A is equal to A. B is equal to B. What is that property? What is that property that says you are, in fact, equal to yourself? Hogan? It is the reflexive property. You need to learn this one. I'm going to put a big old star by it. Maybe I'll put several stars by it. You need to know this. This will work for angles too. If a triangle shares an angle with another triangle, that means those are in fact congruent by the reflexive property. So AB equals AB, or AB is congruent to AB because that's the reflexive property. And now we can go ahead and we can use our side, side, side. And this one's already written for us. This says triangle ABC is congruent to triangle ABD. Those are two simple ones that show up a lot, where we use a midpoint and we use the reflexive property to get that third side. And sometimes there'll be both in there. Maybe there'll be one that's reflexive and there'll be one where there's a midpoint in there. Those are the two big ones when we're dealing with side, side, side. All right, some positional terms real quick. We're going to use the term included. We're going to use the term included and the term opposite. So in this case, if I'm looking at angle C, it's all perspective on what angle you're talking about to begin with. So if I look at angle C and I ask you what side is opposite angle C, well, you're going to say that's AB. It's the one that's directly across from it. That's what makes it opposite. Now, the new word is probably going to be included. Included means it's locked between these two items. Directly between these two items. So if I look at A and B, if I look at angle A and angle B, together they form this side right here. This would be the included side. So included means it's directly between those two things. This can work for angles too. I'm going to say angle B is included between. Now, an angle is going to be included between two sides. So two sides form an angle, just like two angles would form that side. Can you please not write on my tables? So angle B is included between. Now we're going to put up the two sides that comprise it. So that would be side AB and side BC. So included means it's locked between those two items. Angles are included between sides, and sides are included between angles. If I looked at angle B right now, if I looked at angle B, what would be the side opposite angle B? What side would be opposite angle B? Yeah, Hogan. AC would be opposite angle B. Perfect. So AC is opposite angle B. So it's all about perspective. I'm going to say angle C is included between what is angle C included between? What is angle C included between? Grant? Say that one more time. BC and we have one more. And AC. Perfect. Those are the kind of the sides that comprise it. Can you pick up your head, please? So when I say included, we have to understand what's happening. It's between those two things. So BC is between those two. All right, let's move on. We're doing one more. You can go ahead and turn because you gotta get this stuff. I know. He was in the bathroom. He's going to have to watch the video. I don't want you to miss notes because he missed notes. All right, side angle, side postulate. So we had side, side, side. Now we're going to have side, angle, side. So if we read this, it says if two sides and the included angle. Two sides and the included angle. So, for example, C is included between BC and AC. So if I'm talking about BC and AC, I have to be talking about angle C to fit this description. If I talk about BC and AC, I can't talk about B, I can't talk about A. It has to be included between the sides. So if two sides and the included angle, that's the big thing, the included angle of one triangle, I should say one, triangle is congruent to two sides and the included angle of another triangle, then the two triangles are in fact congruent. They have to be in order. So what I typically do is for this one, we have side, angle, side. Do you see how it follows? If I would have A as an angle and these two sides, that would be angle, side, side. You have to say them in order as they appear. Either you read it clockwise or counterclockwise. If I read it counterclockwise, it's the same thing. Side, angle, side. You have to be able to read them in order for it to fall under this umbrella. So once again, we have a side, angle, side. So those triangles are congruent because, well, we would have AB. AB is congruent to DE. We would have BC, well, we can go angle. Let's go angle, what was that? Angle B is congruent to angle E. And finally, we have our sides. We have BC is congruent to EF. That is side, angle, side in order. Then our two triangles are in fact congruent. So we'd have triangle ABC would be congruent to triangle DEF. So side, angle, side. So we know side, 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 and we have side, angle, side. Those are the two ways that we can show triangles are in fact congruent. They're the only two ways we know right now. Bless you. So if I'm looking at any proofs Either on the notes or on the homework, I'm looking for one of those two things. Either I'm looking for side, angle, side, or I'm looking for side, side, side. And here's a good thing to start putting in the back of our cabezas. Do you see how one of my givens gets me an angle? I'm probably not using side, side, side. If I'm finding an angle, I better be using one that we have to use angles for. And right now we only have side, angle, side. So that's what I'm going to try to force this into. So let's go ahead and make some marks on here. So the first mark I'll make is, well, JM is in fact congruent to LN. So I should probably mark that up. JM is congruent to LN. That is a given. Then we talk about angles. So we have angle JMN is congruent to angle LNM. That is also given. Be careful on how you do these. If I give you 3 letters, you have to be specific on what 3 letters we're talking about. So I'm actually going to highlight this. So if it's JMN, look at what I highlight. JMN highlights this angle right here. So I'm going to go ahead and put a congruent symbol on there. Then for our next one, it talks about angle LNM. I'll highlight that in green. LNM, so that's this angle here. So it's not side, 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 because I only know one side. I know a side and an angle, so I must be able to force this to be side, angle, side. Is there a way to find that other side? So I have sides congruent, I have angles congruent. I need to prove that one more pair of sides are congruent. Can we do that, or is this not solvable? Is there something we literally just did? I had you highlight it and put, I need to know how to use this. Is that on here at all? What was that? The reflexive property. Look at this shared side. That shared side automatically means I can put tick marks on it. It shares that side. So I can say NM is congruent to NM because of the reflexive. And now I have side, angle, side, and side, angle, side. So both of them are matched up from side, angle, side. So we are done. We're on step 4. That is triangle JMN is congruent to some triangle, but it's by side, angle, side. Take a second and try to fill in this missing triangle.
Which one?
The only one I'm missing. That one right there. So right there. So I haven't named it yet. I want you to go ahead and name it.
Should be LNM.
LNM. It's okay. We'll check it either way. We'll check it. I'm not going to go off it. We'll check it. So this is how I would check it myself. So notice how JMN. I would actually go around the circle and see how that works. So JMN goes one tick mark, another tick mark. All right, this one's LNM. I'll do that in purple. L, one tick mark, M, another tick mark, and on top of that, this angle should match. Yeah, that looks good to me. Questions on naming that triangle? Okay, so this test will definitely not all be proofs. We'll have some stuff that we can just show that we know the information even when we struggle with proofs. So this one says, state whether the triangles can be proven congruent. If possible, by side, 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 or side, angle, side. So only if they're possible. There'll be ones that we can't prove congruent. I want to make sure I get to one of those. Okay, so for the first one, can we prove those triangles are in fact congruent? Either by side, 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 or side, angle, side. I heard a yes from Daniel. Why? What would you use?
SAS.
You would use SAS because we could see we have a side, an angle, and a side. And here I also have a side, an angle, and a side. So can these be proven? Yes, and I would use SAS, our side, angle, side. Now I'm going to pick a triangle for you. I'm going to pick triangle QYT. What triangle is that congruent to? So I picked QYT. It is your job to pick the other triangle's name. I'm going to get. If you are stuck and I call on you, we can just work it out together. Hogan, did you get this one named? KPC. Let's check that out. So QYT, 1 mark, 2 mark.
Sent to you and Dad. Jesuit will next convene.
Okay, so we have 1 mark, then 2 marks. KPC. K to P goes 2 marks, and then no marks. So Hogan, was that correct? No. Do you want to change that?
Wait, why didn't you do C first?
I didn't pick it. We're just going through options. So that turned out not to be correct. Hogan, so we need to go 1 mark, then 2 marks. Can you find a direction that would go 1 mark and then 2 marks? KCP, so that would go 1 mark and then no marks though.
Or CKP?
CKP would be correct. Yeah, there we go. Does that make a little more sense, Hogan? All right, cool. I know you kind of get put on the spot and all of a sudden you're like, ah. Okay, our next one. I can either prove it side, angle, side, 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 or I cannot prove it. Well, I only have 2 sides marked, so does that mean I can't do anything because it's just side, side?
Yeah.
Joseph, you're shaking your head no?
No, you can't use that.
Well, I'm sorry, I couldn't hear Joseph. Yeah.
Reflexive thing.
We can use the reflexive property to come up with a third side. 1, 2, 3, I can use that reflexive property. We need to remember that reflexive property. It shows up so many times. It shows up so many times. So now we can say side, side, side. I'm going to name the first triangle because it's always the hardest one to do. I'm going to make it easy enough. I'm going to go ADC. ADC is congruent to what triangle? I was going to randomly call him, but Ty's hand went up immediately. What do you come up with, Ty? CBA. So Ty said CBA. Does anyone disagree with CBA? Look at it. I said ADC, and Ty went with CBA. Is that right? It is right. Yeah, it is. I just made it sound like it's not right. Okay, we're going to do one more together. And then I'm going to release you to do the rest of these. Our last one, 4. And there are some harder ones. I did the easy ones. 4 is a little bit more difficult. Do you see how we have a side, and an angle? So my first thought is, this is side, angle, side. Am I correct that this is side, angle, side? Am I correct that this is side, angle, side? Let's go through it. If this was side, angle, side, I could say in order, side, angle, side. So I have side, side, angle. Does that say side, angle, side? Is this angle included between these 2 sides? Is this angle included between these 2 sides? Is it included between these 2 sides? Is this side, angle, side? No. Grant.
Maybe we should start on the side from the one tick mark and then go to there.
Sure. So we'd go side, angle, side, angle, all the way to this side. But the only ones I know are this one, this one. I don't know any of this information. You have to know it in order. So none of this is known. So in order for this to be side, angle, side, I'd have to know this side here. or I'd have to know angle S. You have to know it in order. Does that make more sense? You have to know it in order. You can't just say it. You have to know those elements. So if I was to do side angle side going the opposite way, I would have to know that side, which I don't. So this is not side angle side. In fact, this would actually be side side angle, because if I say them in order of how we did it, we'd have side side angle. And I'm going to tell you right now, you will never, ever, ever use side side angle. It's not one of the mystery ones that are coming up. You will never, ever use side side angle. You know it doesn't work because if you say it in the wrong order, you can't really say it out loud, which is kind of a nice, convenient way of knowing that these are not congruent. All right, you have 3 more. You have 3 more. I want you and your partner, or you and the people in front of you, or you and the person behind you. You could take a second, work on them by themselves. Ask questions of each other. When you raise your hand and you say